Today we're going to flip coins, roll dice, deal cards, and talk about 649's lottery jackpot. If you have gambling issues, be warned. A random experiment is a setup with random outcomes. You should be able to identically repeat the experiment as many times as you please. Like rolling a die. Even though the outcome from a single repetition is uncertain, you can create a list of all possible outcomes. Such a list is called a sample space. Going on a blind date is a random experiment. The sample space includes instant regret, awkward silence, and sudden urge to escape. And just like dice, you never know which face you'll get. An event in probability is just a set of outcomes from the sample space. The word sounds exciting, like a concert or a parade, but in statistics, an event could be something as simple as rolling an even number. Not much celebration involved, unless you win money. Probabilities are non-negative, sum to 1, and add over the outcomes in an event. If you ever calculated a probability and got minus 0.7 or 1.2, take a coffee break and try again. Equally likely outcomes are more of a mathematical ideal than a natural law. We design coins and dice to be close enough to fair that we treat them as equally likely. But in nature, most outcomes come with different likelihoods. For example, did you know that baby boys happen more often than baby girls? The ratio is roughly 105 boys to every 100 girls. So even at birth, outcomes aren't equally likely. Empirical is what you observe in your random sample. Theoretical is what you calculate based on your random experiment assumptions. If they disagree loudly, either the math is off or your model assumptions are off, or both. In the game of Monopoly, a sum of 7 shows up most often, not because it's lucky, but because it has the most favorable pairs. If you want to empirically approximate this theoretical probability, just roll a couple of dice a few hundred times and record the outcomes. You'll notice 7s pile up quickly with relative frequency of approximately 0.1667. You will also notice some strange looks from your family. Here's another problem similar to this one. A hand of 5 cards is dealt from a well-shuffled standard deck of cards. What's the probability of exactly 2 aces in the hand? Imagine each month is a chair. How many ways can you seat 5 people in 12 different chairs if no one is allowed to sit on someone else's lap? The first person has 12 options. The second one has 11 options, etc. Two peas guarding the ends like bouncers, or should I say pouncers. Everyone else squeezes in the middle. This arrangement has a likelihood of about 1.8%. The real lesson, probability says, save your money. But if you do win, remember who explained the odds. It's true. The formal study of probability began in the 1600s with gamblers asking mathematicians like Pascal and Fermat to solve betting problems. In other words, probability grew out of gaming tables and dice, not lecture halls. So next time you play roulette, just remember, you're standing in the birthplace of modern statistics.